This video will look at proving slope criteria in quadrilateral types using coordinates. That means we'll be looking at graphs to prove these. To begin, let's look at our quadrilateral definitions. I recommend that you fill in the diagram with the marks and write the definition as we go along. The parallelogram is a quadrilateral with opposite sides parallel. The way we show parallel is the arrows on the segments. The first two sides have the single arrow indicating that they're parallel to each other, and then the top and bottom have the double arrows indicating that those are parallel to each other. The matched number of arrows indicate which sides are parallel. The rectangle. The rectangle is a quadrilateral with 4 right angles or 4 90-degree angles. The way we're going to show that is the boxes. The boxes indicate a 90-degree angle. The rhombus. The rhombus is a quadrilateral with all sides congruent. That means all 4 sides have the same length. So we'll put a single tick mark on all 4 sides. That indicates that all 4 sides are congruent. The square. The square has the properties of the rhombus and the rectangle, meaning that all sides are congruent and it has 4 right angles. First, let's show that all sides are congruent. We'll use the tick marks. Second, we'll show that all 4 angles are right angles by putting in the 90-degree boxes. The square has the 4 congruent sides and the 4 right angles. Now we're going to be asked to prove that we have a parallelogram, a rectangle, a rhombus, or a square on a graph, and we need to look at what these definitions have. Well, within the definitions, I see that we have parallel sides, congruent sides, and sometimes right angles. So what would it take to actually prove that we have parallel sides? Or to prove that we have congruent sides? Or what would it take to prove that we have a right angle? How do I do this? It gets down to what evidence do I need to prove this? The evidence that I need to be able to show that I have one of these 3 things. Well, let's look at some examples of how to prove this. Let's start with parallel sides. I want to know, are these segments parallel? But I need to prove my answer. It's not enough to say they look parallel. Well, the definition of parallel is that the slopes must be equal. So the way to show that these segments are actually parallel is we're going to find the slopes of both segments and show that they're equal. Let's start with segment AB. We'll draw on the slope triangle and can see that it has a rise of 9 and a run of 6. The slope of that segment is 9/6, which reduces to 3/2. Now let's turn our attention to segment CD. We'll draw on the slope triangle and see that the slope triangle also gives us a slope of 9/6, which reduces to 3/2. Because both slopes are equal, we know that these segments are parallel. So it's okay to say now that AB segment and segment CD are parallel because they have the same slope. Now, let's look at what it takes to prove that segments are congruent. Congruent means that the lengths must be equal. Now notice that these are diagonal segments. If they were horizontal or vertical, we can count those, but diagonal segments require that we use Pythagorean theorem to find that diagonal length. Now we're going to draw on the slope triangle like we did before, but we're going to use those in Pythagorean theorem. The Pythagorean theorem says that leg squared plus leg squared will always equal the hypotenuse squared. So in this case, 9 squared plus 6 squared is going to be equal to our AB squared. 9 squared is 81, 6 squared is 36. The sum of those two numbers is 117, so AB squared is 117. However, AB would be the square root of that. So AB is the square root of 117 units. Now we don't need to approximate this because we just want to show that the other segment has the same value. So let's go ahead and now do segment CD. We need to actually draw on the triangle again. And then we can go ahead and find the length of CD and verify that it is the same. Plugging it into Pythagorean theorem, we get CD squared equals 9 squared plus 6 squared, which we know from above is also going to give me root 117. Now we've shown that segment AB and segment CD are congruent because they have the same length. They're both the square root of 117 units long. Alright, lastly, what would it take to prove that segments form a 90-degree angle? Well, 90-degree angles come from perpendicular lines. Perpendicular lines form 90-degree angles. But what does it take to prove that lines are perpendicular? Perpendicular lines have slopes that are opposite reciprocals. So what we're going to need to do is find the slopes of both segments and show that they're opposite reciprocals. If the slopes are opposite reciprocals, then the segments are perpendicular, and if the segments are perpendicular, they form 90-degree angles. So let's start with segment AB. The slope of the segment is 6/9, which reduces to 2/3. We'll draw on the slope triangle for CD and see that the slope is going to be -6/4. -6/4 reduces to -3/2. Now notice 2/3 and -3/2 are opposite reciprocals. Because they're opposite reciprocals, we know that the segments are perpendicular. And if the segments are perpendicular, we formed the 90-degree angle. So here we can say segments AB and CD are perpendicular because their slopes are opposite reciprocals. And then by the definition, this means that angle AEC, or any other of the three angles that are there, with the vertex of E, are going to equal 90 degrees. All right, let's recap. What evidence do we need to prove? Depends on what we're trying to find. If we're trying to show that we have parallel sides, the way we're going to do this, we're going to show that the slopes of those sides are equal. If we're asked to prove that we have congruent sides, then we're going to show that the lengths of the sides are equal. Now keep in mind, lengths and slopes are not the same thing. The length we use Pythagorean theorem. And lastly, if we want to find that we have right angles, we're going to show that the sides are perpendicular, that is, their slopes are opposite reciprocals, and then say that they form a 90-degree angle by the definition of the 90 degrees.